So we have learned about sets, right, in school times. What is a set? Let's say this is some set X, okay? Then this is some set Y. So when I'm saying set X and set Y, these are attributes of a table, okay, of single table. Let's say this is our table class, and this is one attribute X of that class, and this is one attribute Y. That's what it is. X and Y, two different sets means two different attributes of the same table. So what's a functional dependency? So we used to create some functions, right? Like this, some functions we used to create. F of, let's say some function F. What does this mean? This means if let's say I'm writing x1, x2, these are the elements, x3 and x4. And similarly, respective elements are there, y1, y2, y3, and y4. So what does this mean? What does this function means? This function means using this function, there's some definition in this function, right? If we are taking an input argument as x1, let's say this is our function. If we are taking input argument as x1, so that's what a function is. So what is happening when we denote this x to y? That means where x is a set of attributes that is capable of determining the value of y. So in machine learning or in general in maths concept, this is known as these input arguments are known as independent events or independent columns. Okay, they're independent, right? They can be anything. They have full independency. Okay, independent columns, independent attributes, independent features, and these are dependent features. Okay, this set is dependent feature. It's a dependent feature, dependent attribute. That's what it is. So that's what functional dependency means. We can create a function. We can create a function which can help us in deriving y attribute from x attribute values. So whatever I explained, what's a function which is creating some relationship, right? Some input is there and some output is happening, which belongs to this particular attribute y. Okay, and the input is coming from here. So that's what function is creating. It's creating a relationship between x and y. So either you can call it independent variable, or you can call it determinant. Okay, or this is anyway dependent variable. Because these complex understanding the maths behind these concepts, that's not very important for the interview purpose as well. That's good for gate exam, or if you're going for any net JRF or something, but not over here. Yeah. Because it will take a lot of time for me as well. It might take 2 to 3 weeks to just to understand the maths behind this thing. Okay. So first one is first normal form. So what's a first normal form? Where multiple values are not there in one entry point. For example, let's say, can you guys see this particular table where student phone number, student state, student country, and student name, all these columns are there? Now, if you'll see over here, there are two phone numbers, right? There are two phone numbers. So it's not a 1NF. Okay, in each and every cell, okay, in each and every cell, there has to be only one value. That is only one phone number. So if we want to create one NF of this table, one normal form, the first normal form, so we will convert this table to first normal form. So what we are doing, rest of the entries, that is one, Ram, Haryana, and India, that we are repeating just that phone number. This we have written twice. So this phone number came to first row, and the other phone number came to second tuple over here. And rest of the entries are same. Okay. So this is how we make This is how we convert a normal table to 1NF, first normal form. That's what first normal form means. Each cell can't have multiple values. Okay, it will have only one value. Is it clear, guys? That's first NF. Okay.
So by this, if we are talking about thread row which is unique, it clashes with that.
Uh, Sorry, if you're talking about that each and every entry point should be unique.
Yes.
Yeah, but we are not checking that right now.
Okay.
Okay, we are not checking that. This is a normal column. This is a normal column. This is a normal column. It can have non-unique entry points. Okay. So we understood about first normal form. That is no multiple values. Okay. Now let's understand about second normal form. What does second normal form means? So in second normal form, first condition is it has to be first normal form. Okay. What was first normal form? Each and every cells will have unique values. Only one value, not unique, one value. Okay. So it is satisfying first normal form. It is, right? Okay, done. Now, what is the second condition? The second condition is no partial dependencies. Okay, no partial dependencies. Only fully functional dependencies are allowed over here. So let's understand what is partial dependency and what is uh, fully functional dependency. And fully and partial dependencies of okay, let's do that. So let's say there's one attribute A. Okay, there's one attribute A. A and B are having some functional dependency. That is same thing. Some function is there, and that function is able to compute this B value with the help of A values. Okay, it's able to derive the values of B. This is one thing. Okay. Now, if in a table we have two columns combining together, and that is deriving C. Okay. If two columns combining together, that is deriving C, then that's a fully dependency.